Welcome to the ATC build. I'm just going to talk about a few things real quick. See, kind of screwed up on the bearing mounting. I was planning on it being a 1 thou interference fit to press the bearing in and it being exactly on size. So I ended up making a plate and shimming it up to hold it for now, but I think I'm going to remachine this whole part here because I've had several different design changes while I was making it, and for some reason the sensor here, I'll bring you in closer so you can see what I'm talking about. So my tool 1 position sensor, I made a boneheaded mistake and drilled it 2 1/4 instead of 2.6 inches. So for the purposes of testing, I just welded a quick screw on there just to make sure the sensor is working and how I had it wired and everything else, debugging. But I think I'm going to rebuild this whole plate here. 16mm linear slides, 12-inch stroke, 1.5 inch air cylinder. Should be plenty enough pressure for that. Back you up a little bit. Here we go. I got sensor for retract, sensor for extend. So if everything goes right, we slide in, release, Z up. When we slide in, the sensor will tell Modbus we're extended. Release the drawbar. It'll send a signal to relay, activate the air cylinder, which is inside the cabinet. I'll bring you around in here in a minute to show you what's inside the cabinet. For now, release, move up, index to the next tool, come down, grab it, and there's sensors on both the pressure and the release side on the drawbar air cylinder. Retract good. This sensor will go off. This one will, turn off. This one will turn on. It'll tell, okay, yep, we're fully retracted. That way, if it gets hung up somewhere in the middle, it'll e-stop. If the drawbar gets hung up, it'll e-stop. And then this is tool 1 position. So on startup, every time it'll index around to tool 1, and then it'll index back to whatever tool slot was left the last time it was on. So say you're using I was using tool 3 last time, tool 3 still in the spindle, it'll index back around to tool 3. That way, if for some reason this got bumped while it was off, because it's just a dumb stepper, it doesn't know where in the world it's at, so it'll index around and go, okay, there's tool 1. Now we know it's this many steps back to tool 3. That way it always knows. And during tool changes, it'll go the shortest route to whatever tool's next. So if I'm going tool 3 to tool 6, it'll go this way instead of going all the way around this way. It'll make the tool change time a little bit shorter. Axle shaft, just 1018 cold rolled. Nothing special. Doesn't machine fairly nice, all that bad. This is a 5/8 nut. 5/8, what's the thread? 5/8, whatever, 10 I think, or whatever it is, coarse thread. For that, I'll go ahead and take this off for you. So, nut, spacer, shaft, that way you can see how much of a slip fit it is. Yeah, without the top on it, quite a bit of wiggle. It is a slight press fit. It's about a 1/2 thou interference fit on the center of the bearing. So I figure about a thou on the outside, get that pressed in nice, and it'll all be pretty good and stiff. I may end up still doing the retention fingers on the top. I haven't decided. We'll see when I remachine the plate. These are all P&P sensors. Let's see, 425 ounce inch stepper. This is a, let's see, yeah, 2-inch XL serpentine belt, or not serpentine, Hot Rod World, it'd be a Gilmore belt, but it's not a Gilmore belt. Anyway, tooth belt for that, and then it has the matching same size pulley for this. I wanted to go a bigger pulley, but it was going to interfere, and I still needed height for my tools. To clear under here. I mean, I could make it just clear and get the bigger pulley if I wanted to and drop this down. But I wanted a good amount of meat here to pull against. It's a double row angular contact bearing there. I want to say it's a VBX is the brand. They're fairly inexpensive. It's a 5202 is the bearing, and then I will bring you around back here. So right now I got it running on a parallel port card, just a C10 card. I had an extra parallel port card for my mill computer, so until the Modbus is done, I was just using this to make sure, you know, motor's wired right, sensors are in. This is just a quickie isolated DC bus for my 12 volt rail. This is 5 volt coming in, 12 volt step direction ground for the stepper. 48 volt DC up here coming in for the driver, and then these are my air valves. So this will be extend retract cylinder, this will probably be the power drawbar, and this will be air blast. And then I also have, so I want to do an air blast to make sure the shanks are blown off before and after we change tools. And then on this side I've been using for the power drawbar, I'll use this for controlling my cool mist. This is my Chinese ghetto cool mist setup, but right now I have it just power drawbars just run off that belt drive conversion up there, Belleville's, yeah. And here's my mill computer. Let's open it up and I'll show you the inside of the cabinet. So here's the inside of the cabinet. We got the VFD X and Y closed loop stepper drivers. This is the stepper driver for my Z. That's a 4,000 ounce inch. Somewhere I think 4,025 ounce inch stepper. It's a pretty big one. That's my 48 volt power supply. And breakout board, and I'm just about out of video, so I'm gonna end it there.